Okay, so those are definitely some ways you can improve the validity of within subjects designs. Again, practice, rest periods, and spacing out the conditions. But let's talk about an additional way, one that you do in pretty much every within subjects experiment, at least that I'm aware of. So I think we've established that this study is not very good because there's so many things that could be changing with time, in addition to the manipulation. So again, puberty is one, any kind of disaster. Just time of year was another one we talked about. So our 12-year-old's going to be maybe more stressed when they're starting school or starting a new year in school than say over the summer, so on and so forth. So in this particular study, practice and rest periods and spacing out conditions are not really an option. But what we can do is something known as counterbalancing. And this is really just mixing up the order of the conditions. Okay. So remember that we talked about how when an extraneous variable, so all these things like time of year, puberty, so on and so forth, those would be extraneous variables. Remember that when those are covariant with the independent variable, they become confounds. When they're randomly distributed across conditions, they're just more acceptable. And often there's nothing you can do about them. But again, when they vary with the independent variable or treatment type or drug type, it becomes a confound. So what we can do is we can actually present the conditions in different orders. And this is what we mean by counterbalancing. So there's a few different ways you can counterbalance. There's kind of full random counterbalancing and then Latin square, which we'll get to in just a minute. But the general idea is that you're going to mix up the order of the conditions, and this is going to offset any effects. It's going to turn the confounds of whatever's going on in these different time periods to just extraneous variables, and we could even analyze for them. So essentially, some people will get the no drug, some people will get this, right? They'll get the no drug here at this time point, the placebo at this time point, and the new drug at this time point. Other people, though, will get a different order. They might get the new drug first in the earliest part of the year, then the no drug in the middle part of the year, and then the placebo last. And then lastly, some other people will get the other order, which would be placebo first, no drug, and then new drug. So the idea behind counterbalancing is that you're going to have an equal number of participants to get condition A for whatever condition A is. Some people get it first, some people get it second, some people get it third. An equal number of participants will get A before B and B before A, so on and so forth. Okay. And generally going to randomly assign people to the order that they get. So again, thinking back to this issue of confounds versus extraneous variables, because I don't want you to forget that. If we're so order could be, it certainly could be an extraneous variable in any experiment. But remember, it's not a confound, it's just an extraneous variable if we randomly distribute it across conditions. So if order is an extraneous variable, then logically we want to mix up order, right? We want to make it so that some people get one order, some people get another order, some people get another order. Therefore, any effects of order should be equal across conditions. Okay? Order is no longer systematically varying with the independent variable. Right? So again, if everyone was getting the same order, then we no longer know, is it the independent variable that's having the effect of a treatment type, or is it um, is at the time of year they're being tested or being measured. But again, if we mix these up and each person gets a random order, then it's no longer, the extraneous variable of time of year is no longer covarying with the independent variable. It's just random. Okay, so more specifically, this is what counterbalancing usually looks like. One method is to do a more full counterbalancing and just think of all the different orders which the conditions can be presented, and if condition, and then you're gonna try all those orders for individual participants. So let's say we only have two conditions. Well, that's pretty easy to counterbalance. Half of the participants will get condition A first, half will get condition B first, and then half will get A second, and half will get B second. Look at it that way. Okay. And just kind of to hammer this point home, we'll kind of keep talking about this. But what's going to happen to both? So we talked about how time of year might be a confound here, but what do you think is going to happen in terms of, say, practice and fatigue effects here? Just looking at the A and B one, or the A, B, B, A counterbalancing. Well, any effects of practice or any effects of fatigue should offset, right? So let's say that B's condition drops, mean score drops because of fatigue, right? Well, if we only have this order, then again, we don't know, is it A versus B, or is it the fact that when they do B, they're tired? However, when we have both versions and some do A first and some do B first, now we should be canceling out that fatigue, right? Because now we know that half the people are doing B second and half the people are doing A second. So any effects of fatigue should be equal across conditions. Okay, let me say that one more time. By mixing up the order, any effects of fatigue should be equal across conditions. And then, of course, the same logic applies for practice effects, right? So let's say that if we only did this version, just did A first, well, now we don't know, are they doing better in B because they have more practice, or is it because of this manipulation? Well, again, if we do both versions and we have some people, half the people do A first, half the people do B first, then we know that any improvement due to practice is going to be equal across A and B when we combine these. Right? That's what we mean by offsetting these order effects through counterbalancing. Okay, moving on, kind of the most thorough method of counterbalancing is to do basically every version possible. So you do, if you had three conditions, you do A, B, C, A, C, B, BAC, BCA, CAB, and CBA. That's kind of the most thorough method of counterbalancing. That's full counterbalancing, another term for it. So if you have two conditions, I mean, that's easy. Three conditions is not so bad because it means you're going to have six versions of the experiment. That was just this one here. With three different conditions, we end up with six different versions because there would be six possible orders. However, sometimes it's not really worth doing full counterbalancing. Sometimes it's better to use what's called a Latin square design that we'll get to next. For example, if you have four conditions, then you end up with 24 different versions, which who wants to bother with that, right? Who wants to write four different programs for an experiment? That seems a bit excessive. So the more, I'd say, commonly used method is, again, the Latin square design. This is just going to mean that the number of orders is going to be equal to the number of conditions. So three conditions would give you three orders. and instead of 6. So obviously for something with, say, 4 conditions, you're not going to end up with 24 different versions. You'll have only 4 versions. So here's what that looks like. Rather than going every possible combination, you're basically just going to shift everything one way. So if you have ABC as your main, or say your first version of the experiment, well, then you're also going to shift everything left. So now B is going to, so it's ABC with B second. Now B becomes first, and C moves from third to second, like you see here. And you get BCA, and then A goes all the way to a third condition. Done. And then you do it one more time. So B gets shifted all the way to third, and then C goes to the left, and A goes to the left. It doesn't really matter which way you shift it. Like you could go, okay, A is going to go here, then you'd have C, A, B, and then B. That would give you the same result. Just these two would be switched. But either way, you're going to switch. You're going to move everything down either right or left, the same amount of times as conditions. So again, A is going to go to second, B is going to go to, or in this example, rather, A is going to go to third, C is going to go to second, B goes to first, then C to first, A to second, to third. So you're still in some way maintaining the order, but every condition is going to be appearing equally often at each spot, so to speak. So in other words, each condition is going to be first once, second once, and third once. Or actually, once is probably not the best word. Let's say equally often, because you're going to run. Let's say you run 9 people. Well, you're going to get 3 of them are going to get this order, 3 get this order, 3 get this order. So again, each condition will appear equally often in each spot. So here's just another example of Latin square design. Again, 3 conditions will mean 3 orders. Each condition is first once, second once, third once, but then multiply it for number of people you're running. It's just the pink part here. So ABC, BCA, CAB. Again, everything is shifting one spot over, and therefore it's going to appear equally often. Each condition will appear equally often in the first, second, and third spots. Again, the same logic should apply here to all carryover and testing related effects. So let's say we're dealing with fatigue here. Well, in this condition, in this version of the experiment, condition C might show some fatigue effects beyond whatever the manipulation is. But because C is also going to appear in the second and first spot, those again should cancel out. Right? If C were to only occur here, that would be a confound, but it's not. C is also going to occur equally often in the second and first position, canceling out those order effects. Just a little refresher here. So remember that if a constant order condition is confounded with order, and this affects the internal validity of the study. We no longer know, is it an effective order, maybe a practice or a fatigue or a carryover effect, because that's confounded with whatever your manipulation is. It's not an issue of external validity, it's internal validity because it's a confound and it's affecting, whether the study is whether you're actually manipulating what you say you are. External validity is, does it actually generalize to the question of interest? Now, sometimes counterbalancing is not good enough. Sometimes you get carryover effects that might not be equal. So what's a good example here? Let's think again of our chocolate experiment. So let's say you wanted to know which which chocolate do people like the most? Do they get actually let me get a better example and come back to that. Okay. Yeah, I'll come back to that issue in just a minute. Um, so yeah, we kind of already covered that. One last thing you can do if you are pretty concerned about carryover effects, um, although they should be offset through counterbalancing, um, sometimes you still do want to track that. Because again, let's say you're running the cell phones and driving experiment, but you're pretty sure, for whatever reason, you don't just do practice trials. You are concerned about pretty substantial practice effects here. Well, that's not going to be a confound, but it is going to add kind of some extraneous variable to your study. So it might make it harder to see an effect just because there's this extra thing going on that's not being factored into your analysis. Again, it's not a confound because it would be equal across groups if you counterbalance, but it would still add some noise. If that's the case, sometimes what you'll do is just analyze. Um, you'll kind of treat it like you'll treat it as an independent variable. So you actually run an analysis for order effects in addition to any effect of your variable. You're not actually interested in, well, not too interested in are there order effects because there probably will be, but just by analyzing for that, you can actually improve the precision of your study, so to speak. Okay. So again, I'll give you an example of that thing I mentioned before. Order effects are not equal, but just to review, a within subject design is ideal when there could be pretty substantial individual differences. All studies are going to have individual differences, but when they're really heavily related to your dependent variable, it could have a pretty big effect. Then you might want to use a within subjects design. Easy to find versus difficult to find participants. Well, difficult, right? Because in a within subjects design, you need less people. Um, so therefore, if you're having trouble finding people, might be a good reason to do a within subjects design. Um, and the last one might be if you're interested in cumulative effects of the conditions. So there might be rare cases where you're interested in what how things will add up over time. If people do one condition, then another, and you really are actually interested in the order, um, kind of how it all comes together, that might be another reason to do it within subjects design. But there aren't too many examples of that. Um, okay. And then a couple more things. Again, less participants needed. That's kind of a pro of within subjects design. Another big one that we didn't spend much time on is that within subjects design is ideal whenever your manipulation is not obvious. Or alternatively, knowing when the manipulation is not a problem. So let's say I'm running some sort of memory experiment and it's about picking a strategy to study for exams. Well, in that situation, if I'm taking that and looking to actually apply that to people, it shouldn't really matter whether they know about it. Well, it should still work if they know about it, right? So say comparing taking a practice exam versus rereading your notes. Say that was my research question. Well, in that situation, they probably will pick up on the fact that, say you run that as a within subjects design, they will pick up on the fact that for one part of the study, they're doing a practice exam, and then for the other, they're maybe rereading their notes. Well, we shouldn't really care if they figure that out, right? It shouldn't matter. It's a good memory strategy either way. It shouldn't really matter too much if they're aware of it or not. In fact, we're going to be actually, if it worked, we found a significant result, we might be recommending it to students as a study strategy. So again, it should be able to work even if they know what the manipulation is. So that might be an example where a within subject design is good because you don't care about them figuring out what the manipulation is. Another example is, again, cell phones and driving. I mean, shouldn't really matter if they know that's what we're testing. So why not let them do both conditions? And then the other one is when the manipulation is not obvious. So let's say you're writing some sort of study and it's really hard for them, or pretty much impossible for them to figure out what the manipulation is. Like, let's say they study something differently differently early on, and then they have to recognize it later. But it's really hard to remember or impossible to remember what you did when they were studying. Well, that would again be an example of where the manipulation is not obvious. And even if they did figure it out, it shouldn't really matter. When manipulation is not obvious, then it should be fine to use it within subject design. On the other hand, let's say you come across something you want to manipulate where them knowing what's going on is a problem. That's often the case in a lot of social psych experiments rather than cognitive. So let's say you were looking at something to do with discrimination, and you had them interview a job applicant, and say it was a man versus woman or whatever it might be. Well, in that situation, there's a good chance that people are going to be figuring out your manipulation and be skeptical of it. So if you have them interview someone, let's say a man, then you have them interview, say, a woman, they're probably going to figure out what's going on. And that could definitely affect their results. Okay. That might really screw up the study because the manipulation is easy enough to figure out, and it's also problematic if they do figure it out. Once they because you're kind of interested there in what are their natural responses. Would they hire these people at equal rates? So if they figure out what's going on, again, that's going to mess up your study. So in a situation like that, you really need to use a between subjects design because the manipulation is too easy to figure it out. And if they did figure it out, that would be a problem. The last one is if carryover is pretty minimal. So again, I mean, it all just depends on your research question. Like we talked about before, you can analyze and filter out carryover effects. You can treat order like an independent variable, but even still, sometimes it's just the carryover is just too big, too substantial, and it's not worth doing it within subjects design. So in those situations, so again, something like say a memory test where the two conditions are very similar or involve similar information, that might be better to just use a between subjects design because there's going to be so much carryover due to what they're trying to remember being so similar. It's probably better to just run it between subjects. To give you one more example of when within subject design is not useful is again when they're figuring out when they might figure out what the manipulation is. So there's a lot of classic studies on false memories where you manipulate the wording of a question. For example, you might have them watch a car accident and then ask them how fast were the cars going when they smashed into each other, or you might ask them how fast were the cars going when they bumped into each other. So just changing bumped to smashed to into. You get different results in terms of false memories there, but the point is that in a situation like that, you can't really ask them the same question twice because obviously they're going to figure out what's going on and their memory's already contaminated from trying to remember it. So again, that would be a situation to use a between subjects design. Okay, next up is factorial design.